Welcome back. Today we are solving one of the most important and most asked about in interviews topics in Salesforce, the security model. By the end of this video, you will know exactly who can see a record, who can edit a field, and how Salesforce decides all of that. We will go layer by layer using one simple example throughout. A hospital app with patients, doctors, and nurses. Let's begin. First, organization-wide defaults, or OWD. This is the floor of your security. It answers one question. By default, when a record is created, who else besides the owner can see it? There are 4 choices. Public read/write. Anyone can see and edit. Public read only, anyone can see, but only the owner edits. Private, only the owner and people above them in the role hierarchy can see it. And controlled by parent, used for child records like line items, where access simply follows the parent record. In our hospital example, patient records contain sensitive medical data, so we set OWD to private. Nobody sees a patient record unless we explicitly give them access later. Roles are about hierarchy like a company org chart. If junior doctor reports to senior doctor, and senior doctor reports to department head, then the department head can automatically see every patient record owned by everyone below them. This only works if OWD is private or public read only. It never works the other way. A junior doctor can never see the department head's records just because of the hierarchy. One mistake beginners make: confusing role with profile. Remember this simple line: role controls who sees records vertically. Profile controls what a user is allowed to do. If role decides who can see a record, profile decides what that person is allowed to do. Every single user has exactly one profile, never 0, never 2. A profile controls: can this user create, read, edit, or delete a record? That's called CRUD. Can they see a specific field? Which apps and tabs appear in their interface? Even what hours of the day they're allowed to log in. In our hospital, the nurse profile might allow read and edit on patient records, but not delete, because we never want a nurse accidentally deleting a patient's medical history. Now imagine one nurse, just one, needs temporary access to delete patient records. Maybe she's covering admin duties for a week. Do we change her whole profile? No, that affects nothing else and is messy to undo. Instead, we create a permission set called something like temporary patient delete access, give it delete permission on patient, and assign it to just that one nurse. Her profile never changes. When the week is over, we simply remove the permission set. Think of it like this: your profile is your permanent employee ID card. A permission set is a temporary guest pass clipped on top. It adds access, it never takes access away. Here's a real situation. Patient OWD is private. Role hierarchy lets managers see their own team's patients. But what if a radiology nurse in a completely different department needs to see patients flagged for an X-ray, patients she doesn't own and isn't above in the hierarchy? This is exactly what sharing rules solve. A sharing rule says, take records owned by this group or matching this criteria and share them with that other group automatically for everyone going forward. There are 2 types: owner-based, which shares by who owns the record, and criteria-based, which shares based on a field value like needs X-ray equals true. Now here's a subtle but powerful concept. A receptionist might be allowed to open a patient record to check the appointment date, for example. But should she see the doctor's private diagnosis notes? Absolutely not. That's where field-level security comes in. Even though she has access to the record, we can hide or lock a specific field inside it, profile by profile. FLS has 3 states: visible and editable, visible but read-only, or completely hidden. Let's tie everything together with CRUD. CRUD simply means create, read, update, delete, the 4 basic actions any user might perform on a record. CRUD permissions are set at the object level through profiles or permission sets. FLS works at the field level. Here's the critical part for you as a developer. When you write Apex code, by default it runs in system mode, meaning your code can completely ignore all of these security settings and access everything. That is dangerous. So as a responsible developer, you should add the keywords with security enforced in your SOQL queries to force your code to respect CRUD and FLS just like the user interface does. Imagine you're inserting a new patient record, but a required field is missing. Without exception handling, Your entire code crashes and the user sees an ugly error screen. Exception handling lets you catch that problem gracefully. We use try-catch finally. Inside try, you put risky code that might fail. Inside catch, you write what should happen if it fails, maybe show a friendly message. Finally always runs, whether there was an error or not, great for cleanup. Salesforce has built-in exception types like DML exception for failed database operations, null pointer exception for when you try to use something that doesn't exist, query exception when a SOQL query returns the wrong number of rows, and list exception for invalid list indexes. You can even create your own custom exception, like invalid age exception, for business-specific rules. Static is one of the most misunderstood keywords for beginners. So let's go slow. Normally, every object you create from a class gets its own separate copy of its variables. But if you mark a variable as static, all objects of that class share that one single copy. Same with methods. A static method belongs to the class itself, so you can call it without even creating an object, just by writing classname.methodname. Here's a very practical, real-world use in Salesforce. Preventing a trigger from running twice in the same transaction. Because static variables only reset when a brand new transaction starts, you can use a static Boolean flag to say, I've already run once in this transaction, don't run again. This is called recursion control, and it's used in almost every production trigger handler. Final is simple once you see it. A final variable can be given a value one time, and after that, it is locked forever for that variable. Why would you want this? Imagine a business rule. A doctor can never be assigned more than 20 patients. That number should never accidentally change somewhere deep in your code. So we write it as a constant using static and final together. Static means there's only one shared copy. Final means it cannot be changed. Together, this is exactly how professional Apex developers write constants. Access modifiers answer one question. Who is allowed to see or use this piece of code? Think of 3 circles, one inside another. The smallest circle is private. Only code inside the same class can use it. The next circle out is public. Any code in the same application or namespace can use it. The biggest circle is global, visible from absolutely anywhere, even from a different Salesforce org if you're building a managed package. Here's a trap many beginners fall into. If you write a variable or method with no modifier at all, Apex automatically treats it as private. Many people assume no modifier means public. That is incorrect. Here's a very common real-world problem. You want to show a list of patients on a page, with a checkbox next to each one, so a doctor can select multiple patients at once for a bulk action. But the patient object has no isSelected field, and you don't want to add a permanent field to your data model just for a temporary UI checkbox. The solution is a wrapper class. You create your own custom class that holds the actual patient record plus any extra fields you need just for the screen, like that Boolean checkbox. Our final concept, utility classes. As your project grows, you'll find yourself needing the same small piece of logic in many different places, maybe checking if a date falls on a weekend. Instead of writing that logic again and again in every class, you put it once inside a utility class made of static methods and call it from anywhere using classname.methodname. One important distinction. Don't confuse a wrapper class with a utility class. A wrapper class holds data for display. A utility class holds reusable logic.